and plus minus 2k3 plus 2k3. This is 0. And the last element k1 plus 4k2 and plus 7k3 is equal to 0. So you have this system of equation, these three equations, which I am writing in this blue box. You have these three system of equations. If you solve this system of equation, one of the solutions will come out to be, because you know how to solve the system of equation, you can check that one of the solutions will come out to be k1 is equal to 3, k2 I guess is 1, that is written on the slide, and k3 is equal to minus 1. This is one of the solutions. So that means you have 3, 1 here, and minus 1 here. Okay. So this means that the vectors are not linearly independent, because k1, k2, k3 all are not 0. So we can say that these vectors are linearly dependent. Okay, and with these values, it has been shown in on the slide that you can obtain one from the other. For example, if I want to obtain the vector 5 to 7, the third vector, then what you do is you multiply 3 in the first vector and add this to the second vector. So if you do this, you get the third vector. So that means third vector can be obtained by the linear combination of the first two vectors. Therefore, they are not linearly independent. That means they are linearly dependent. All right. So here the calculation is also given, which I have just written with the pen here. So one of the solutions is this. You have infinite number of solutions for this system of equation. This has infinite number of solutions, and one of the solution is this, which is a non-zero solution. That means you are able to find at least one non-zero solution of the system of equation. Therefore, the vectors are not linearly independent. Okay. So I will stop here. If you have any question, you can ask me, and will discuss the other things in the next lecture.
Sir, what is the meaning of homogeneous set of equations? Means homogeneous, basically.
Homogeneous means the right hand side is 0.
Oh, okay.
So if you have this system of equation, let us say Ax is equal to, A is a matrix, B is X is a vector, Ax is equal to B. So if B is equal to 0, then we say that this is homogeneous. Otherwise, it is non-homogeneous.
Okay, sir.
Sir, can we get the updated slides after the class?
So after the corrections. Yes, I have
Okay,
already
sir.
sent before the class the slides. Have you got that?
Okay, sir. I will just check. I think I have not checked.
Just before, just 1 minute, 1 minute or 2 minutes before the class, I sent the updated slide.
Okay, sir. That's okay, sir. Thank you.
Okay.
Sir,
so anything else?
the
Yeah, go on.
So what is the significance of linearly dependent and independent? Like why what we can get from that?
The use of linear independence and dependence will come into picture when we discuss the rank of the matrix.
Okay, sir.
Okay.
Sir, sir, I had a doubt from the previous class. Sir, why row reduced form is unique but row echelon form is not?
This is basically when you start making the zeros, more and more zeros. So in let me show you. So if you just consider these first three elements here, so in a row echelon form, the target is to make these elements 0 and these elements as 1. Okay, but if you make these elements also 0, then you will end up with a unique, but only with the elementary row operation. Then you will end up with a unique element. So that is why this row reduced form is unique, row echelon form is not unique.
Okay, sir.
So non-uniqueness of row echelon form is very much clear, because if you have one row echelon form, then you can have another row echelon form. For example, if I have this, just consider the first three columns of this. Right. So I can also say that I have 1 0 0 0 1 0 1 0 0 1. So this is also row echelon form because you have 1 here. But when you start making these elements also 0, then you end up with a unique one. All the elements are 1, diagonal elements, and the remaining elements you try to make them 0, as many zeros as possible. Then you end up with a unique one. Mathematically proof is a little bit challenging. Writing is challenge. Understanding is not challenge. Writing is a challenge. Any more questions?
I have a doubt in example 3.
Example 3.
So here we already know that we cannot find solution without having 4 equations because we have 4 variables. So can we directly add x4 is equals to t over here and add a row in the matrix A matrix as 0 0 0 t at the last?
Yeah, you can do that.
Okay,
But you know, if you do this, then slight complications can arise. The reason is that if you try to reduce this in row echelon form, so what you get is that in this final form, you can clearly see that it is easy to express x1 in terms of x4, x2 in terms of x4, and x3 in terms of x4. So from here, it is clear that if I take x4 is equal to t, then I do not have to do further calculations. But if you say that if I take x1 is equal to t, and you have done this in the beginning, and then some slight more calculations may be needed. Otherwise, you can do this.